Bismillahirrahmanirrahim. Students, welcome to virtual session of databases, week 8. So, can you hear me? Please raise your hand if you can hear me. Okay, thank you. So, I was looking through looking at the contents of week 8 of databases, and I wanted to cover those contents in today's session. But then I realized that the complexity of topic is such that they need a face-to-face session, and because you have your midterm exam on coming Monday, so it is better to prepare for exam than to study a new topic. So I'll be covering the content of because in last week as well I have covered some of the contents of this week. So only few things are left which can be covered in week 10. So in today's session I would like to focus on your midterm exam preparation, and because I told you that the most important activity, most important thing which you should know to pass your exam is how to make your entity relationship diagram, how to solve any issues with entity relationship diagram, how to resolve many-to-many relationships, how to represent them in relational schemas, and how to normalize your relations or entity relationship diagrams, entity relationship diagram. So what I'm going to do today is that I am going to give you some practice question. I was just exploring the web and found some good examples which can be shared. So what I'm going to do today is to give you some question, and then you try to solve it, and then I'll be telling you the answers. So in this way we can prepare in a better way. Okay, let's start with my first question. If you get a question like this, so wait for a second. I'm going to paste it for your display. I'm using it for the first time. Using this tool for the first time, so pardon me if you feel certain. So can you read it? Yes, I think 18 point is okay. So you may be asked a question like, explain the distinction among the terms primary key, candidate key, and super key. So do you know its answer? Like in a short question, if you are asked, explain the distinctions among the term primary key, candidate key, and super key, what would be your answer? Yes, primary key is a unique key, right? What is candidate key? So isn't candidate key unique? No, it's not like that. Primary key is unique, but candidate key is also unique. Candidate keys are also the candidates to become primary keys. So they are also unique, but the database designer picks one of the candidate key as primary key. Okay, so let me tell you its correct answer. Like if I ask you this question, now I'm going to tell you answer from your book. This is answer. Like a super key is a set of one or more attributes that taken collectively allows us to identify uniquely an entity in the entity sets. The super key, so in super key you have multiple sets, and each of the sets allow you to uniquely identify entity in the entity sets. So a super key may contain extraneous attributes. If K is a super key, then so is any superset of K. A super key for which no proper subset is also a super key. Like a candidate key is the one which cannot be further broken down. A super key can be broken down, it has certain subsets, but candidate key is the one which cannot be broken down further. Like for example, if you are combining ID and age, if you skip ID or age, any one of these, then it will not be a candidate key. So candidate keys cannot be further reduced, and it is also unique. Now it is possible that several distinct sets of attributes could serve as a candidate keys. Like in a table you have multiple candidate keys. So the primary key is the one of the candidate key that is chosen by the database designer as a principal mean to identify entities within an entity set. So the database designer is picking one which is called primary key, but candidate keys are also unique. Okay, now let me ask you another question. You may be asked, a question like this. Like, yes, super key is a superset. So it contains all the keys which are uniquely identifying. So all the super keys, each one of the super key is also uniquely identifying each of the entity in your entity set. Like if you combine all the attributes of your table, like if you have a table with student ID, name, age, GPA, super key is like ID, name, age, CGPA. If you combine all, it is a super key. If you make it name, age, CP, GPA, it is also a super key. So there are multiple super keys which are uniquely identifying, and the super key is the multiple keys which are uniquely identifying, and super key is the set of all those keys which are uniquely identifying. And one of them which cannot be further reduced is picked up as a candidate key, and there can be many candidate keys of same size. Now from the candidate keys, the one picked by database designer is called primary key. Now a question can be like this, like you can have a question like this. ID will be an attribute included in the super key set. because super key is a set which contains all the keys which are uniquely identifying your entities. So ID will be included in that super key set. So if it is uniquely identifying, it will be candidate key as well, and it will be, if chosen by database designer, it will be primary key as well. Okay, now a question can be like, you may be asked to construct an entity relationship diagram for a car insurance company whose customers own one or more cars each. Like, there's a car insurance company and they have like many customers, and each of the customer has one or more cars, and now each car is associated with it 0 or any number of recorded accident. So each of the customer is having one or more cars, and each car has encountered 0 or many accidents. So you have to make an ER diagram for this. Now I am giving you 5 minutes for this activity, that at least you identify entities, and then I'll be back after 5 minutes. Okay, students. So you are some of you are working on it, and some of you maybe not. So I asked you a few questions. That is customer an entity? Yes, because entity is something about which you want to record data. So we want to record details about customer, like their ID. So it means it is an entity. Now car is an entity because for each car you need to store certain information. So like you have stored for a car, like its model number, its year, its color. Car accident is also an entity because you want to keep track of, because each customer has one or more cars. So it means for one customer you have to record details about cars, and each car has its own associated number of accidents. So you need to have, because there are multiple cars, so you have to make car an entity. Then you have 0 or more recorded accidents, so there will be an entity for accident as well. But in case of accidents, you don't need to keep data about car brand and car ID number, as Munira just identified. Rather, you just need to keep details about accident, like if it was an accident, what was the reported date, what was its location, what was the time. So you need to keep details about accident only. Okay, the details about cars are already kept in car entity. So in accident, you will keep details about accident. Now then I ask you a question, that is car insurance company an entity? So can you answer me? That is car insurance company an entity? Anyone else? Car insurance company is an entity or not? No, it's not. And the reason is because it is having only one instance. Because there is only one car insurance company. So you won't make it, the entity will be the one having more than one instances. Since there is only one company, so you don't need to make a separate table for this and have its only instance in that table. So if there is something which has only one instance, so you don't call it an entity. Now let me tell you its solution. So this is the solution, and as you can see here, there is a different notation being used now over here for ER diagram. You can see that there are three entities in this diagram. So this is also one of the notation used in if there is more than one branch of company, then you will keep details about branch. But in the description about car insurance company, because you are not given that our company has multiple branches, so you will not keep this information. So whenever you are asked to make an entity relationship diagram, then you are making it, then you should, even if you are saying that they have more than one branches, you should specify in text that you are assuming, you are making assumption that the company has more than one branches. So you have to just write it below your ER diagram so that it can be correct. Okay, now you asked some question. I can make a relationship between car insurance and each car. No, car insurance company is not a entity, so it's not required. So now let's see its solution. Here you can see three entities: person, car, and accident. The attributes associated with each is person. For person, you are keeping name, address, and ID. Driver ID, it can be any ID. It can be driving license number or any identification number. Then car, you are keeping its license number, model, year, or you can keep color or any other information you want to keep with it. Yes, you can write, but keep the information. Unira said that I can write another information under each entity, not exactly what you write. You can write, but when you are writing it, be sure that you are not recording too many attributes. You should keep only the attributes which are required. So it is not like, even if I talk about person, I can record name, address, age, gender, phone number, and many things as well. But these are not required. So keep only the key information, basic information. Make it as simple as possible, because later you will have to remove this information. Amal, do you have any question? Amal Shaheen, you raised hand. See, now in this ER diagram, we are just recording, because you are an insurance company, you are just recording details about your customers and their cars. Okay, so it means you are keeping, so all the cars and persons in your database will be insured because you are providing insurance. So all these details are for insurance. Yes, yes, you can write customer. I would say that exactly this should be customer instead of person, because in the description customer word is used, so we should use customer over here as well. So this is one of the solution I found. So I have just okay. Now person, you have recorded name, address, and ID. Car, license, model, year. For accident, you are recording the report number, location, date. On which date accident occurred, what was the location, what was the report number. Okay, and when you will be linking them with car, it means now you are keeping, like if I see relationships now, person owns car, okay, and what kind of relationship it will be? It will be one to one, one to many, many to one. What it will be? What do you think? One person can own one or more cars. Okay, so it means it is one to many. And then because every car will be belonging to some person, so on this side it will be one. One car is owned by at least one person. But a car cannot be owned by multiple persons. So it will be from person to car, it will be one to many. Now, I said each car is associated with it zero or any number of accidents. So, from the car side, car participated in accidents. So, it will be one car has associated zero or many accidents, so it will be many from here, and it will be one over here, because we are recording details about one car. And in participation relationship, we are keeping another information that is damage amount, or we can keep information about driver as well, like who was the driver at that time. No, because car will be linked with accident through some relationship. The relationship is participated, because in accident the person may also be participating who was driving the car. So this is a ternary relationship in which person, accident, car all are linked. You said what you said? You said many car might be for one person, so why it is not many to one? That's why I'm saying that from on person side it will be one, on car side it will be many. Because when you will be reading, one person can own many cars, and one car will be owned by one person. So it will be from person to car. If you read person to car, it will be one to many. Yes, we will make it binary. Like if you see here, this ternary relationship, when you will move onwards, you will resolve this here, because this is initial ER diagram. And whenever you are given a textual description and you make an ER diagram, it should be further revised. So here it is ternary relationship, which should be resolved. It will be resolved later when you will be designing your relational schema. So the ternary relationship should be resolved. So it will be resolved later. Okay, is it clear? So can we move to the next? Okay, I'm moving to the next example. Let me try it again. This is your next question. Our university registrar's office maintain data about following entities: courses, including their number, title, credit hours, syllabus and prerequisites; about course offerings, including course number, year, semester, section number and instructors, timings and classrooms; about students, including their student ID, name, program, and about instructors. Further, the enrollment of students in courses and grades awarded to students in each course must also be modeled. Construct an ER diagram for the registrar office. Document all assumptions that you make about mapping constraints. So remember, whenever you are making an ER diagram and you are assuming something, in your answer you have to write your assumption. Okay, so I want you to identify entities and their attributes and their relationships, and then make an entity relationship diagram. I'm giving you a few minutes, and please think about it, and then I'll be showing you its solution. So try to understand as many things as possible in today's session, and ask questions whenever you are not clear about something, because the similar type of questions will be coming in your exams too. Okay, so let's talk about it for 5 minutes, and I'll be back after 5 minutes, and meanwhile you come up with something. Okay, now you can see solution here. The entities are students, instructor, course offering, and course. Now you can see that the details we are recording about students are ID, name, and program. Student enrolls in according to the course offerings. Course offering contains attributes, time, section number, room, year, semester. And instructor teaches one of the courses from the course offering. And instructor has associated attribute of ID, name, department, title. Course offering has courses offered, and about courses we are recording details like as given in the description, course number, title, syllabus, credits. And since the prereqs is also the course, so it is having this kind of relationship which we already studied in slides that this way it appears. So this is a entity relationship diagram. So this is, and remember, this is one of the notation in which entity relationship diagram is there. There are many other notations, and you should be familiar with all of these notations. And if making while making the diagram, you are making certain assumptions. You should write all your assumptions that I assume in this ER diagram. I assume this. I assume this. So you write your assumptions besides your ER diagram, and if possible in exam, like if you are constructing your diagram, you can give textual description of the diagram as well, so that will be more good. You cannot make it only a relationship, because I said that entity is the one having more than one instances, and it has more than one instances. Now if we talk about course offering, we have to store course number, year, semester, section number, instructor, and all these things. So instead of making it only a relationship, and which you ultimately will have to break down, because it will have many-to-many relationship with other entities. So it's better to, and there will be ternary relationship as well among instructor and student and course. So it's better to make it as an entity and link it with all the other three and have separate relationship. Like this, we break the relationship R into RA, RB, and RC in a ternary relationship, if you remember. So it would be more good. Now after making this, you may have to normalize this as well. So think about normalizing it in terms of first normal form, second normal form, third normal form as well. Okay, so these are some of the questions which I have just shared with you, and practice for similar questions as much as possible for your exam. So because these will be in your so let me give you another question as well, which you can, because our time is going to be up, but you can practice for that after our session is over. So for normalization, what you have to do is first identify, like you have been using tables in normalization, so try to make it in a tabular form, and then after identifying all the attributes, think about it that if some of the attributes will have are having more than one instances, make it in first normal form, and then see what will be the primary key. Because in here I have not identified primary key, I have not identified the foreign keys. So when you will convert the ER diagram into relational schema, then you can come up with a you can normalize it. So first make it in a schema and then normalize it. Okay, I'm giving you another example which you can practice later. Yes, sure, you can normalize and you can send to me. I'll I will tell you that whether it is correct or not. Let me paste another example for you. So this is another question which you can practice later. Just take a screenshot of this so that if I close this room, you can view it later. I'm using exercises from I think I shared this exercise link with you in my virtual session of week 6. If you can look at the previous recording, maybe you would be able to find it, because I just okay, I can share its link again. From there I have got this. There are a lot of other exercises as well which you can practice. Okay, now you can go directly to this link and see see all the practice exercises, their solutions, and you can practice running.